Okay, part C, it says here, in 2012 it was recorded that the total mass of paper used for printing newspapers in the world was 2.88 times 10 to the power 7 tons, and the world population then 7.2 times 10 to the power 9. Now it says use this information to calculate the mass of paper per person used to print newspapers in 2012. So they basically want you to work out an average of how much newspaper each person in the world gets. Okay, on average, based on the total mass, then of course divide by the world population. And you might not see that formula, but if you look closely here, it kind of gives it away to you, because it says mass of paper there, right, which is essentially this here, yeah, total mass. And then per just means divide. Okay, so we're going to divide, and then person, of course we're talking about how many people are there. So that's what we're going to do, this divide by this. But before we can do this divide by this, we need to get it in this unit here, because it says kilograms per person, and the mass is in terms of tons. Okay, so ton is quite a large, so quite a heavy sort of weight. If you think of like the weight of a car weighs about a ton. Okay, and the conversion for 1 ton is 1,000 kilograms. Okay, so if you think of 1 kilogram as like a bag of sugar. 1 kilogram is a bag of sugar, so a ton is 1,000 bags of sugar, right? Which would be about the weight of a car. All right. So here we need to change this into kilograms, yeah, to get this formula working properly. And if we've got this amount of tons, remember each ton is worth 1,000 kilograms, so we need to times this by 1,000. So 2.88 times 10 to the power 7 times 1,000. Okay, now that looks kind of nasty, but if we kind of keep things in standard form, you'll realize you've got 2.88 times 10 to the power 7, and 1,000 is just 10 cubed, right? Right, and then you can simplify this. 2.88, keep it in standard form, and when you've got powers of 10 here, you add the powers, so this will be 10 to the power 10, you add 7 and 3 there, and we're done, right? We've got the total mass there in kilograms, right? So we've got one step, we're picking up marks already. Now we go to the formula, right? And remember, mass of paper, so we've got it here, right, in kilograms. So 2.88 times 10 to the power 10. And then, of course, we want to do per person, so we're going to divide by how many people there are in the world. And that's already given to us there, 7.2 times 10 to the power 9. Now, ordinarily, when I'm dividing, right, or even when I'm multiplying standard form values, I keep it in standard form. Okay, that's what I tend to do. That's the principle I use, because it's easier. It tends to be easier. But in this case, if I keep it in standard form, it could cause problems, because I'd have to divide these two, and it's quite hard to divide them. Okay, it's possible, right? But it's hard. So what I would actually advise in this case is to actually change these now into ordinary numbers. Okay, they're going to be big, right? But I would do that. Okay, so we're going to have a big division line here, and you'll see then that the answer comes out quite quickly if you do it that way. Now 2.88 times 10 to the power 10. Now, of course, with standard form, when we think of the decimal point moving, it's got to move 10 places. And because it's positive 10, the decimal point will move to the right 10 places, so it become a really big number. Now, there's already digits after the decimal point, so the decimal point will have to move 2 places to get to the other side of them. So we've already moved 2 places. As it's got to move 10, we're going to need to have another 8 zeros, if that makes sense, right? So 288. Okay, so now if you think about it, the decimal point has gone from there, it's on its way, it's moved 2 places, and we need another 8 places. Okay, so it moves 10 places, as the power says there. So 8 more places, so 8 zeros we need to put there. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, got to get the right amount of zeros there. This then, 7.2, so we've got to move the decimal point 9 places to the right. Okay, and we're going to have, of course, it's going to move 1 place to get that side. Okay, so it's 1 place, and then we're going to have another 8 places for it to move in order to get 9 movements in total. So we're going to have 8 zeros. 7, 2, 1, 2, 3, 4, 5, 6, 7, 8. Now, hope you noticed, right, you remember 8 zeros on the top, 8 zeros on the bottom. So they will actually cancel out in terms of division, right? So we can scale this down, and the zeros will cancel out, okay? We're knocking off 8 zeros, so effectively we're dividing by top and bottom by, what's that, 100 million, I think, is 8 zeros. Top and bottom, scaling it down. And we end up with 288 divided by 72, okay? And that's actually not difficult to do, because if you think of 72, when you double 72, think of what you get. You get 144, okay? So if you double it again, in other words times it by 4, you get 288. So 288 divided by 72 is just 4, okay? And there's our answer. So mass of paper, each person receives 4 kilograms.